Hey, welcome back on my channel. So today the proxy design pattern. So this one is a really interesting one. So basically you can shield or hide your implementation from your real consumer, from your client, and you can add extra property or you can manage your resources basically. Okay, so before we begin, so the question of the day is, do you think that TDD, test-driven development, is still relevant in 2023? So only honest answer, that's fine. If you think it's not relevant, it's okay. I'll give you my opinion in the comment later. Alright, so then for today, as usual, you're gonna have a code example. So the proxy design pattern has multiple applications. So I decided to go with the caching proxy example. So I'll implement a cache mechanism with you today. Then we'll have some discussion about pros and cons as usual. And finally, I'll put a link for the code. So then you can clone yourself the repo and play around with it, or you can just try it by yourself if you want. Alright, so just before I leave it to you for the videos, please don't forget to like and subscribe if you enjoy this kind of content. It's like some recognition for me for all the work on the video, and I will understand that you like this kind of content. I'll do more. Alright, thank you very much and enjoy your video. Okay, so let's crack on. So I will create a new directory called proxy for the that design pattern, and I'm creating a subfolder here called consumer. So you'll see it in action really shortly. So essentially we will create a database, and we will create I'm creating right now a consumer to consume that database, but we will rely on an interface first, and then you will see how we can swap with the proxy seamlessly. So the goal of the game is, from the point of view of that consumer, the database will never change. The interface will never change, and we can always rely on that database, but the consumer will have no idea how the database is accessed, basically. Okay, so here you just saw I just done something doomy with an empty struct and with a process method, and the process method is just logging something. So as usual, we can just try that out. So if I run that main program like that, so it's running, and then you can see init, which was the log I put in the consumer code. Right, so now creating a subfolder with the database. So database is a big word, so here we will just print, we will just write and read from a JSON. So it's a tiny database. Okay, so as I said, we will work with interface. So here it's the I database interface. So very Java-y. I don't recommend you to write I for your interface. So, but here just for the sake of simplicity. So I want to struct input with an ID and a content, both string, and my interface is essentially setting an input and then getting an input by its ID and returning a string, which will be the content. Okay, so that's my interface, and I'm creating another file for my implementation. I can just call it simply database, and we will have file. So my file, it can be a property of that service, so then you can just change file if you want. A little bit of flexibility there. And here I'm I was about to write it by hand, but we can just use my ID shortcut. So here I can just choose to implement an interface. So we call it iDatabase. So there you go. You can see it's putting all the function for you. Okay, so let's start with the set. Sorry. Hay fever is killing me. Sorry about that. Okay, so for the set method, so essentially when we receive an input, we just want to read the file that was declared on line 6, and then append to that file the new input. So when we read the file, os.read file comes back as bytes. So we need to unmarshal that file. So let's just be simple. So the JSON file will just be key and value. So there you go. So this is how you unmarshal JSON files. You read it, then you declare the struct, then passing a reference from that struct, and then unmarshal it. Obviously, line 16 may or may not return an error, but we can ignore it for now. Okay. So line 18 is just like appending our new input to that map. So in Go, you just do angle bracket the key equal the value you want. So the map data is then updated, so then we can do the whole operation back. So we need to marshal that new data structure. So we can just call it updated db bytes. And then we just need to write back to the JSON, to the file. So you can see the signature there. So the function is write file. So it needs a file name, the byte, and file mode permission. So here we just put the necessary permission. Okay, so we can try that out. I'm just gonna put the ID on the terminal on the right. So yeah, let's just create a constructor for it. And so here we need to seal our consumer with the interface. So either we could put it directly in the struct, or either we can just simply put it in the process signature, just for simplicity here. So the process method is taking an interface. So then you do know that the set and the get method will be available. You don't know about the implementation, but you are guaranteed to have those functions. So here we will just append one and hello as a message. Right, so then it means that we need an implementation in the main program. So here we can use our constructor like that, and the file. So I'm in that path, so then it's gonna be design pattern and proxy, and then the name of the file. There will be a tiny issue here because it's the function calling the OS, that relative path, is not the main program, but it's database. So that path won't be recognized basically. There you go. So you can see there's some panic and some nil entry. So essentially when you get a panic, you are trying to understand where it's come from. So okay, so here you can see that it's saying is nil map, so it means that it's probably not instantiated. So that's the first feedback for you. So when you unmarshal the file and there's no data, basically no map instantiated, we have to instantiate it. So there you go, we will just make an empty map. So then if we run that again, so you can see we have a different error. We have no error at all actually, but you can see that it didn't do what we wanted. So it didn't set ID1. So here I'm just checking things, but somehow I will realize that it's that path. So I'm thinking, and then it's probably gonna put a log line on line 20. There you go. So we will log that error. It's returning an error. So let's try that out. And you see it's saying unexpected end of JSON input. So it's actually not. Yeah, so first I thought that I didn't create it, so maybe it can't find it, because we didn't write, we just brutally say just write to that JSON, but it's not guaranteed that the file exists first. So I thought it was that, but it still say unexpected error. So it means that it's probably above. It's probably the error I underscored on line 18 on the OS read file. So I'm still trying to debug. Big brain time. So here I'm trying to instantiate it manually just to see if it can read it, and still can't read it. So I'm thinking. It's probably why you in real life you don't ignore those errors, because if I would have written the error check on line 18, I would have found it straight away. That's what you do in real life and when you do TDD and you write your tests. But here I'm trying to focus on the learning rather than those tiny debugging thing. Right, so I'm gonna fast forward a little bit, so then you'll see how I corrected it. Okay, so here finally you can see that I put I've logged the error and it said that that path doesn't exist. So then I understood that my mistake was the relative path. So I hope it's not too boring for you to for me to show you some errors I can do, because I'm like you, I can make errors. I'm not perfect, so this is how you debug things. Okay, there you go. So then the relative path is not correct, so then I just put one level up. So then you can see nil, which is the no error essentially. So then if I go to the db.json, we should have our 1 and hello. So there you go, the marshal. And here I just realized where the code was invoked basically. There you go. So you can see 1 and hello. Okay, so all good. So we have if I just rerun that, it's idempotent. So it just, if it's there, it's gonna override on that key. So all good. Okay, so now the second method, the get the access method. So Let me just tidy a little bit there with no error. So the get, essentially it's a map, so it's quite easy. So first step, we obviously need to read the file again because it's just a JSON layer. And if the map is coming back empty, we will protect ourselves by building an empty map. And then the way you access a value from a map is just angle bracket, so it will return you the value if it's there, or if it's not there, it's also returning you a boolean. So the boolean is false if it's not found and true if it's found. So if it's not found, we can just return the string not found simply, and otherwise the value. So you can see here there's a little bit of repetition, so we can come back to that later to refactor a little bit, some quick win. And then here, if I try to use my get method, so if I look for the ID2, and we can log that, I should get not found, and then if we look for 1, we should find it. Right, running, compiling, and then you go not found and hello. So all working as intended. Okay, so as I was saying, there's a little bit of repetition there. Right, so let's start by, you see that map string, so that's not really pretty, that's really raw, so we can define our own data type here. So we can define the type data, which is just a map string, and then from there we can create utility function. So if I just shift the reading file and unmarshalling it to just return a fully typed data structure, it will be a bit cleaner. So then here, my from file, so essentially I give a file and then I'm getting back data. And then here I can change that to its strongly typed structure. So let's try it out. So all that can go. So I need, so it's a struct method, so I just need an empty struct to attach it. It's a bit weird, but it's fine. So it's a static method in other language. Jeez. So yeah, I just tried it quickly, so it works. So then it means that then I can replace that in the set. So you can see that they are shrinking. They have shrunk a lot, so that's good. It's good refactoring. And then, so if you have from file, you can have 2 file. There you go. So from the data structure, you output to a file. So you can hide that from the set and the get. Actually, the get doesn't use it, but the set use it. It's just a way to clean things up. So what it is right now is the type data is dealing with IO, essentially. It's like the get and the set has no idea how the database itself worked the layer below, and it's held by the data structure. So if you want to swap the file and the JSON by, let's say, a real database connection and an XML format, it's all done in the data layer, not in the get and the set. Okay, so if I try that out, so I just change the content for the value, for the key 1 to good afternoon. So there you go. Still working, so happy. Okay, so essentially you have a JSON database that works simply. So now the proxy pattern. So we want to use the proxy pattern as a cache proxy pattern. So proxy means that it's in front of it and you don't see which addition it does or how does it manage the real resource from your consumer point of view. So the value of the cache here is that instead of reading the file each time, we will give a grace period basically. So when you ask for an ID the first time, the cache will hold it in memory for a certain period of time. So then during that period of time, if you're constantly asking for the same ID, the cache will just give what it's in its memory, in the cache memory. Or when the cache is expired, we will make the real query to our database again. So that's how cache works. So here you can see that I just implement my I database for the cache, so it's exactly the same signature. So the set is the same, so the set will just, we can't really cache a set method, so it's just pinging our real database and set it. But then here I'm gonna declare a cache data struct. So it has the content, but also a expiration date, expired at. So it's where things are getting a little bit hairy there with the get. So the cache struct has, as I said, a cache data in memory and just a map of string, but then here it's the cache data, not string as the real database. Alright, so here when a request comes to the cache, we can just check the cache first. So there's a few cases here. So if it's not found, it means that it has never been queried on the cache. So we will simply make the request to the database. So then just .get ID. And then because it's the first time we made that query to the real database, we need to cache that data. So then the expired at is just the time now and then the grace period. So we will add 3 seconds of grace period. It means that if you still query for that ID, within the 3 seconds, we will give you back the cache data. Otherwise, we can make a fresh query. Okay? So if the value is there, we can return the value. But we need to add another condition there. So it's value content because your cache is returning expired at and content. But then we need to write another condition because the value might be there, but the value might be expired. So we need to add another condition. So the condition is found, but the cache is expired. So it means that it's okay, it's found, and the time, like right now, is after the grace period, after the expiration date. Okay? So then in the if statement, we need to do not found or found but cache expired. There you go. So found but cache expired is a boolean. So then you can just see some booleans composition. Okay? So that's the proxy cache. So then from the consumer's perspective, we can maybe add a few set and get, but as you can see, I haven't changed any method on the consumer point of view. It still has get and set. I haven't changed the proxy yet. So let's say we set the ID 1 and then we get ID 1, but then we set ID 1 to something else and we're gonna try to get it. So we do 2 gets, 1 set 2 gets, and then 1 set 2 gets, but we will put a sleep duration. So then it should force to the cache to refresh its data. Okay? And I need to swap in the main program for the cache. Right. So here, if I run without the cache, you can see like the two gets a good afternoon, and then just after switching the key, it's giving back good evening straight away, and then the time that sleep doesn't matter, it's returning me good evening. Okay, so here back to the main, so we have a database. Now we will declare cache. I haven't created a constructor, so ID shortcut there. So my constructor, you can take the responsibility here to instantiate your cached data map. So then you do know that there's already one instantiated, so you won't have nil map error. Okay, so then you cache, so then it needs a database like that, and then we can just simply send the cache. Okay. Okay, so here I just modified the end of the consumer, so I'm putting 2 seconds more and with a get. And here actually line 29. So in the case that it's not found and it's making the first query, we need to return obviously the content of the database, not the letting to reach the value content. So there you go. So then you can see the 3 first are good afternoon. So you can see the third one is still good afternoon, even though there was a set instruction. And then you can see after 2 seconds, it got good afternoon still. And then once the cache is expired after 4 seconds, 2 plus 2, you can see it's reaching good evening. So this is a simple cache, and this is a simple proxy pattern dedicated to that caching pattern. So it's quite simple. So then from the consumer perspective, it has no idea that the data actually shielded and protected, so you can't hammer that database if it's expensive. It's protected by the cache. Alright, so now a little bit of a discussion about pros and cons for that proxy pattern. So hope you found it useful. So let's start with the pros. So as I repeated multiple times during the code example, you can manage and hide complexity for clients. You can completely control the lifecycle of your objects. So that's a really good pattern to do that. And that's the intent of the pattern. You can have lazy instantiation, meaning that if you're pinging your proxy, maybe your service is not ready or not even instantiated, so you will instantiate an expensive service only if your proxy has been hit on a certain threshold or on a certain rate. That's really good for this kind of situation, for databases or for threshold or alarms, for instance. So keep that in mind. And obviously it's a really clean design, so you saw that it works really well in Go because we do have a nice interface system. So then from that consumer's perspective, it didn't even know that we implemented a cache on the top of the real database, and it's managing all of that for you. So that's really good. So then on the other hand, for the cons, so careful with the response time. Obviously, if you do add a proxy in front of your real implementation, be mindful if you're dealing with really low latency services, make sure you don't add any extra time on your real service. Ideally, you would do like what we call load test or performance test in real production system, but keep that in mind. Then I know I gave you the example of caching. It's quite simple and quite elegant and so on and so on, but really don't cache if you don't have to. Cache on a real life example, caching is really horrendous to maintain, and to even the cognitive load, just the like it's not beginner friendly at all. So if you build a service and your service is not as fast as you want, just ask yourself first, like, am I using the right tool for the right job? Is it the right language? Is like, why is it slow? Is it a bottlenecking? Is it a database index I forgot to build? Or is it because I'm just using the wrong algorithm, or something like that? And then if you answer to all those questions and you're just in a dead end, yeah, okay, so you can cache then. But if you don't have to cache, don't do it. Really don't do it. And then last one, don't confuse the decorator pattern with the proxy pattern. They both work the same way. They just comply to interfaces and add features, behaviors. But the decorator pattern, the client is fully aware of what's going on and what's been decorated on your service, and probably your client has the responsibility to decorate the real implementation. Whereas from the proxy's perspective, the client has no idea what's going on, and that's the intent of that pattern. You're hiding the lifecycle of your service, like instantiation, access management, caching behavior, that's not known from the client perspective. So being really careful on when you have a technical discussion with someone with the decorator and the proxy pattern. And obviously, if you're trying to interview in some places, that might be a question. That's definitely a question I ask. So be careful with that. All right. So finally, your link to the code you just saw, so then you can use the code and explore by yourself, and obviously I encourage you to try by yourself to make sure you understood the essence of that design pattern, and then if you're stuck, you can just refer to that GitHub if you need. Alright, so I hope you enjoyed that video. I hope you learned something, and for the veterans, I hope it was a good refresher for you. And happy coding. See you next week.